Very good afternoon, Professor Mike. We are very privileged to have you here in our ICCMS 2025 conference. How you are enjoying this IIT Tirupati campus and the ICCMS 2025 conference?
The honor is all mine. I like to be in India, and I was very surprised to be here at the IIT Tirupati. It's a beautiful, very new, very modern place, so I'm enjoying it very much. Also to be with all you guys.
How you are enjoying this climate condition?
Well, I'm not sure if I can really enjoy very humid and hot weather. This is not what we are used to in Germany, but it's no problem for me.
So, morning you have explained about that integral monolithic and bridge construction.
Yes.
Can you, what are the complications will come? Can you explain something?
I think there's hardly any problem or complication with integral monolithic construction. I think there's only advantages, joints and bearings are basically self-fulfilling prophecies. Where you have joints and bearings, you need maintenance, and there's water coming in, there's all kinds of trouble, and sooner or later you have to replace these components. If you don't have them, it's better. If you have a monolithic structure, they're highly hyperstatic structures, so forces and bending moments, they redistribute. You get much more slender structures, you get more elegant structures, I would say. You get lighter structures, you save resources, and since there's no bearings and no joints, you have less maintenance to do and the bridges will last longer. So what's the problem? The only problem, you might say, is that it's more difficult to calculate because due to temperature movements and due to creep and shrinkage, you get extra forces in the structure. And that means that the concrete might crack, and you have to calculate with cracked concrete, which makes the calculations a bit more complicated. You have to consider the movements of the foundation, so you have pile-soil interaction. So the calculations become a bit more complicated, but that only means you have to invest a bit more brain and use less resources.
Can you explain something about carbon in cables and...
Well, we have been working in the field of carbon fibers as load-bearing elements such as cables or tension elements in general, or as pre- and post-tensioning for concrete for more than 15 years now. And I think carbon fiber reinforcement and tension elements have a big potential in the building industry. They are very lightweight, there is no corrosion, there is no fatigue. So that's a lot of very positive properties. So, and the strength is very high, so you can really use this material for cables in bridges, for hangers in bridges, and for pre-stressing concrete. We have actually built a stress ribbon bridge, 50 meter span, with only 1 millimeter structural height of the ribbons. But you can only do that in carbon fiber. And these stress ribbon bridges, they move very much. There's a lot of bending and stress changes, but because there is no fatigue, these stress changes do not really cause trouble.
Could you give some comments on precast bridge construction in India, actually, especially?
Well, my main experience with precast segmental bridge construction in India is the second Vivekananda bridge that was in Calcutta, that was built by L&T and designed by colleagues in India and from Parsons. There, I was very impressed by this technology, by the speed of construction and by the precision these bridges can be built with. In Germany, that would be difficult to do. In Germany, there is basically no precast segmental bridges because the joints are the problem. In Germany, we have de-icing salt, and the salt water goes into the joints, even so if they are epoxy glued, the German authorities would perhaps be nervous about that. And so therefore you see hardly any bridges like that in Germany. But all over the world, yes, you see them. Here we come back to carbon fibers. If the pre-stressing would be made of carbon fiber, perhaps these joints really pose no problem whatsoever, even so there is some water and other liquids coming into the joints.
If you want to give some advice to the young engineers and researchers, what would be that?
Some advice, sorry?
Advice to the young researchers and engineers, if you want to give some advice.
I would give them the same advice that I give to myself, As long as it doesn't look nice, don't do it. So I strongly believe that we as civil and structural engineers, we have a lot of responsibilities, naturally, regarding economy, regarding stability, regarding economy, cost, but also about culture, What we build is very expensive, it's very big, it stands around for a long time, so it better looks good. I think this is very important, that we also think about cultural heritage, and all we do will sooner or later be heritage.
And we are very happy to have you with us. So, do you have any concern about publishing this video content in online?
No, I don't.
Thank you so much.
Thank you very much.